I've always liked these problems where the question will give us a function and then ask us to design a circuit or make a block diagram using a certain set of gates with certain rules that we can't go around just, for the sake of the challenge. So this one here asks us to show a block diagram or to draw a circuit using and or not gates. We also have to assume that the variables are available only uncomplemented, so just as themselves, and we're not allowed to simplify the algebra. So, kind of a challenge, but I'm not going to back down from that. Well, looking at this function here, I don't think it would really matter where you started, just as long as you start somewhere. I think I'm going to start here just at the left just to keep track. And so I'll start with the W here. And the X. So these two are going to be ANDed together, and the X has to be complemented first. So we're going to need a NOT gate, and we can use those. So I'm going to make that happen. So we're going to have our little NOT gate here. Should probably make this bigger. I think we'll have enough. Well, I hope this is big enough to see. So we'll make our little NOT gate here. Oops. I don't know how this problem's going to come out. I don't know how ugly it's going to be or how big it's going to be because I haven't done this out yet. Okay, so we have so far these two, and we need to AND them together. Alright. So I'll just draw our little AND gate here. Okay. Alright, so that's the first part of our problem there. Now this is going to be ANDed with this, all this jazz here in the parentheses. So we're going to draw another little line here and switch gears and go over. We're going to start with the V. No, we're not going to. We're going to start with the Y and the Z. Now the Z we're going to leave alone, but the Y has to be complemented just like the X did. So we're going to have another NOT gate here. That went a lot better than the last one. Okay, so we have this down, and now we have to OR it with the V. So let's put a V here. Oh, I forgot to AND those. Yeah, so those two have to be ANDed together. So So another AND gate here, right? And then the V is going to be ORed with this part of the function here. So I will draw an OR gate. So we have our OR gate here. Gotta make sure that the circuit's connected. That doesn't look good, but whatever. You get the idea. Alright. So we have our OR gate here. Okay. So we've done this part of the problem so far, and now we have to do this part. So I actually might run out of room. I didn't think I was going to run out of room, but there's definitely a possibility. Anyways, all this, we have to AND these together. So we've got the WX0 up here, and then we've got the V or Y0 Z. Yes, okay. And then these two have to be ANDed or ORed together. So we'll do that. And then move on to the second half of the problem. Okay. AND gate. All right. Not too bad. Moving on to the next part of the problem here. So we have W0 and Y ORed with V0. So we'll get that out of the way, and then we'll do this part and then AND them together. Okay, so we have the W and the Y. Keeping these lines straight is kind of a pain, but I think it's worth it in the end. And the W is complemented. So we got our little NOT gate here again. Alright. And these two are ANDed together. So another AND gate down here. And that's going to go to an OR gate. I know that that's going to go to an OR gate because we're going to OR it with the V complement. So we'll just draw that right now. I don't like that. Okay. And now we need this V here. It's complemented V. So we've got the V outputted into a NOT gate to get the complement again. Okay. And that goes to, you can see that that's ORed with this right here, with the W and the Y. The W not Y. Okay. Now this right here, that is what's inside these parentheses. So we have done this, oops, we've done this over here. We've done this. We've done this. Okay, so I just went ahead and moved everything up because I knew we were going to run out of room on this one. So, okay, so moving on to this final part of the function here, we have our x ORed with y and z, and this entire thing is going to be complemented. So there's going to be a not gate at the end no matter what we do. So we've got our x, we've got our y. Let's start with the y and z. Y and z, and then the x down here. And the y and z are ANDed together. I'm going to draw that into an AND gate here. So we've got our AND gate. And we know that that's going to go into an OR gate. And then we also know that OR gate's going to go into a NOT gate. So we'll just draw that now. Okay. And the last thing to do is the x has to be inputted into the OR gate. So we'll do that. And now we have the bulk of the problem done. Now, to finish it off, this here and this here have to be ANDed together. So this and this have to be ANDed together. So we'll do that. Okay. And the output of this here and the output of this are going to be ORed together. And that is our function. You can go back and check the work here. We've got the W, the X naught, the Y naught ANDed with Z, the V ORed with the Y and the Z there, all that ANDed together. That takes care of this side. ORed with the other side. We've got the W naught and the Y, and the V naught, ANDed and then ORed, ANDed with the final part of the function. And that all looks good to me. So that's how you would express a function if asked to draw a block diagram.